Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Alright, which of the three triangles are similar? Write a similarity statement. Okay, so we're going to want to check is triangle LMN similar to triangle RST? So that's one thing that we'll do. We'll compare triangle LMN to triangle RST. And then we need to know, is triangle LMN similar to triangle XYZ? So we'll look at triangle LMN and triangle XYZ. And then we still want to know, well, wait, is triangle RST similar to triangle XYZ? So we want to look at all three of these cases here. We want to know, are any of the triangles similar to one another? So, do whichever one you want first. Since I have the most space over here, let's do triangle RST to XYZ. So we're going to find our shortest side, 24, and put it with our shortest side, 30. And we're going to do 24 over 30. That needs to be equal to the longest side, 33, and the longest side, 39. 33 and 39. And that also needs to be equal to the middle side, whoops, not that, the middle side, 30 over 36. Is this true? Is 24 30ths equal to 33 39ths, which is equal to 30 36ths? Let's simplify these fractions. I can divide by 6 on the top and bottom and get 4/5. I can divide by 3 on the top and bottom here, and I get 11, right? 39 divided by 3. Yeah, 11/13. Right away I know these aren't the same. And 30 36ths, if I divide by 6 on the top and bottom, we get 5/6. Woo! None of these are the same. None of those ratios are the same. So, these triangles are not similar. Triangle RST and triangle XYZ are not similar. Let's look at LMN, and you know what, I'll probably leave this one for y'all. For the sake of time and the sake of space, I'll probably leave triangle LMN and RST for you to do on your own, although you've already done it on your own. You can ask your teacher or a friend, check your work and see if you were right on that one. But let's do LMN together. We'll take the shortest side, 20, over the shortest side of XYZ, which is 30. That needs to be equal to the longest side, 26, and the longest side, 39. And that needs to be equal to the medium side, or the middle side, 24 and 36. When we simplify these fractions, we get 2/3. I can see that because the zeros cancel. Is equal to 26 over 39. We can divide by 13 on the top and bottom. 26 divided by 13 is 2. And 39 divided by 13 is 3. Hey, 2/3 looking good so far. And then this last one, I think we can divide by 12 on both sides. Yeah, and we get 2/3. Yay! 2/3 equals 2/3, which equals 2/3. That is a true statement. So, triangle LMN and XYZ are similar. Okay, so you see an example of two triangles that are similar and two triangles that are not similar. So you can use those to check and see if you were right with triangle LMN and triangle RST. Alrighty. That was a nice review of the SSS, or side-side-side similarity theorem. Let's go ahead and move on to what we have for today. Today we are starting our work in section 8.4. There will be 2 videos on section 8.4. Today's focus within section 8.4 is the triangle proportionality theorem and its converse. So, and other proportionality theorems. In the next video, we'll look at other proportionality theorems as well. But our learning target is that you know what is the triangle proportionality theorem, what does it say, and what does its converse say. The success criteria is that you can use the triangle proportionality theorem, that you understand what it says enough to be able to apply it to a problem, and its converse. So you can use the triangle proportionality theorem and its converse to solve problems. All right, some more vocab review, just like usual. Ratios and proportions. A ratio, the ratio of A to B can be written as a fraction. You can also write it with colons, or you can write it as a fraction, 4 to 1, A to B. And of course, proportions are when you set two ratios equal to each other, or when two ratios are equal to each other. Then they are proportional. Okay. Now let's jump into the theorems, the meat of today, the triangle proportionality theorem says, if a line parallel to one side of a triangle. So in this diagram, they're talking about TU. TU is parallel, that's what those red arrows mean, is parallel. TU is parallel to QS, and QS is one of the sides of the triangle. So if we have TU, and TU is parallel to the other side of the triangle, if it intersects the other two sides, which it does, right, at point T and point U, it intersects the other sides of the triangle. So if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the two sides proportionally. So RT to TQ, that ratio, the ratio of these lengths created by this parallel line, the ratio of these lengths needs to be equal to the ratio of the lengths of the other side of the triangle. So what we're saying is, if I have this parallel line that intersects the triangle and is parallel to the third side, then the ratios of one side, of the segments of one side, need to be equal to the ratios of the other side of the triangle. The converse says the opposite. If we have that that the sides, the lengths, the ratios of the side lengths are equal, well then we know that, oh, this segment that's creating these lengths, because it intersects the triangle at these points, well then this segment must be proportional to the third side. Or must be parallel. Must be parallel. There's lots of P words going on. Proportional, parallel. Ooh. Okay. So remember, the converse, what a converse does is it takes the if P then Q and it switches. The converse says if Q then P. So you'll notice we have if a line is parallel to one side of a triangle so that it intersects the other two sides, then it divides the two sides proportionally. In the converse, we have if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So we take the squiggly part, and like the straight underlined part, and we just switch them. We switch the if and the then. All right, that's what the triangle proportionality theorem says. That's what its converse says. I think seeing some examples will help you wrap your brain around this a little bit more. So, example 1, finding the length of a segment. In the diagram, we know QS is parallel to UT. We know that RS is 4. We know that ST is 6. And we know that QU is 9. What is the length of RQ? RQ is what we're trying to find. So let's name it X. Because we don't know what it is. We're trying to find it. We'll call it X. Now, we know that QS is parallel to the third side of the triangle. Hey, this means that by the triangle proportionality theorem, because they are parallel, that means that the ratios of the length of one side of the triangle must be equal to the ratios of the other side of the triangle. So in other words, X to 9, the ratio of this side, the left side, we have the left side and the right side. The left side is RU and the right side is RT. So the ratio X to 9 needs to be equal to the ratio of 4 to 6. Now, you can't flip these. You can't say 6 to 4, right? If we start at the vertex, we're starting at the vertex. Or, sorry, if we start at the vertex on the left side, we need to start on the vertex on the right. That's what it says. RT to QT and RU to US. So, there we go. Because of the triangle proportionality theorem, we can set up this proportion. So this right here is the work of the triangle proportionality theorem. And we know how to solve this. Butterflies. Cross multiplying. So we have x times 6, or 6x equals 4 times 9, which is 36. Divide by 6 on both sides, and x is 6. We can check. We can check that this is correct by plugging it back in. We have that 6/9 should be equal to 4/6. Is that true? Well, 6/9 is 2/3 if I divide by 3 on the top and bottom. And 4/6, if I divide by 2 on the top and bottom, is 2/3. So yes, 6/9 and 4/6 are the same thing, which means that x equals 6 was correct. Another way we can check our answer is by scrolling down here. We have the triangle proportionality theorem tells us that RQ to QU is proportional to RS over ST, which gives us RQ over 9 equals 4/6. We said RQ was X, and we got X equals 6. Either way, we found that RQ is 6 units long. So, we were correct. Yay! Alright, another example to help you wrap your brain around the converse. First example was about the triangle proportionality theorem. This theorem will use its converse. Because, notice we are given, on the shoe rack shown, BA is 33 centimeters. CB is 27 centimeters. And I'm going to leave off the centimeters. We can bring those back later. CD is 44 centimeters. That's hard to read. 44 centimeters. And DE is 25 centimeters. We can write it on this side. Explain why the shelf is not parallel to the floor. So BD, this is the shelf, right? This is where the shelf is leaning. We can tell it's kind of leaning forward. So we can tell it's not parallel, right? Not drawing those arrows. It's kind of leaning forward. We can see that. This problem wants us to explain why. How do we know mathematically that this shelf is not parallel to the floor? Obviously, we can use our eyeballs, but we want to know mathematically why. Well, we know that if, right, this is what the converse of the triangle proportionality theorem. I'll write THM for theorem. What the converse says is that if the ratios of the sides, right, so 27 to 33 is equal to 44 over 25, if these are indeed equal, then, so if these ratios are equal, then the shelf would be parallel to the floor. So this is kind of, it's similar to the last problem, but in the last problem we knew that these were parallel and we were trying to find a missing side length. Here, we don't know that these are parallel, but if these are equal, then they're parallel. So are these equal? Let's see. I could simplify these fractions, or maybe I can't. Let's do it this way. Let's cross multiply. 27 times 25 is 675. That should be equal to 33 times 44, which is 1452. Whoa! Those are not equal at all. And you can see 27 is smaller than 33. But on the right-hand side, 44 is bigger than 25. So shouldn't we have the bigger numbers, like both of the bigger numbers on the bottom and both of the smaller numbers on top? In order for them to be proportional, the fractions would need to be equal or equivalent. And if I have a smaller number on top, but then a bigger number on top, those can't be the same. So because these are not the same, we know that they are not parallel. So, explain why the shelf is not parallel to the floor. The sides of this shoe rack would need to be proportional. The sides of the shoe rack, the lengths created by the shelf of the shoe rack. So CB and BA, these lengths have been created by this shelf intersecting the lengths of this triangle. And because these are not proportional, then the shelf is not parallel to the floor. That's the converse of the triangle proportionality theorem. So this ratio these ratios are not equal to each other, so we are not parallel to the floor. Let's check and see if we were correct. And sometimes their answer says it in a better way than I do. So, find and simplify the ratios of the lengths. Okay, so they did it in another way. They said 45/25. You can't simplify 45/25. 44 is divisible by 4, 2, and 11, and 25 is divisible by 5. Can't divide anything on the top or the bottom. So that's as simplified as it gets. And 27/33 simplifies to 9/11. 44/25, not the same as 9/11. So BD is not parallel to AE, so the shelf is not parallel to the floor. This is the converse of the triangle proportionality theorem. That's all I have for you today. I tried to keep this video short so that if you do have any questions, you have time to talk to your teacher about it, or phone a friend about it, or text a buddy about it, or something like that. So, now is a great time to assess your understanding of the learning target and the success criteria. Do you know the triangle proportionality theorem and its converse? Do you know what it says? Do you know what it means? Can you split it up into the if, what? I need this, then I can have this. And can you use it to solve problems? Did you totally understand the examples that we went over? If so, help your friends with their homework. Help your classmates with their homework. If you're a little bit stuck or a little bit confused, that's okay. Try the homework. See if you can put the pieces together. And if you are not understanding, you're a little lost, you did not enjoy this video, that's okay. I have been there. We have all been there. So ask your teacher for help. Maybe phone a friend, whatever you need to do to get those questions answered. Here are some practice problems that you can do to practice the skills that you have learned in this video. Some like example 1, some like example 2. And as always, let's end our video with a launch, shall we? The roots of education are bitter, but the fruit is sweet. Aristotle. The roots of education are bitter. I thought that was very interesting, and the reason I put this quote for the launch is I feel like this is different. This means something different to each of us. The roots of education are bitter. We've all had bad experiences with education. So maybe where it comes from. I've had teachers that were not very nice to me. I had teachers that made me very mad. I have had teachers that made me feel incredibly stupid. So those roots of education are bitter. They're not fun to think about, but the fruit is sweet. And if we focus on the roots, if we focus on the teachers that were jerks to us and the teachers that made us feel super stupid, or maybe the materials, maybe like a textbook that didn't include your feelings or your perspective or your culture on a topic, there are bitter pieces about education. And that's why I said this means something different to everybody. There are definitely bitter pieces to education. People that were left out of education due to segregation and things like that. So there are bitter parts of education, but the fruit is sweet. And I feel like if you focus on that bitter part of education, you're never going to want to continue with it. Why learn? There's so much bitterness. My teacher thinks I'm stupid. I don't like them. Ooh, it would be so easy to give up if you focus on all the bitter pieces of education. But the fruit is sweet. Think about the fruits of having an education, right? Going on to college or trade school or something like that. But trade school is also a form of education, right? So getting an education allows you to get a good job that gives you enough money that you don't have to stress. You don't have to stress about finances. You don't have to worry about where is my next meal coming from. You don't have to worry about taking care of your kids or your family. The fruit of education can be very sweet. Not to mention, getting a nice job is great and all that, but also just knowledge is power. The more you know, the more educated of an opinion you can have. It's easy to throw around an opinion. Oh, obviously, the government shouldn't be doing that. Schools shouldn't be doing that. This person shouldn't be doing that. But the more knowledge you have about, oh, this causes this, these things interact in this way, maybe we shouldn't make this decision because this is a consequence that could happen. Knowledge is power. I could talk about this for a long time. The more you know, the more valuable of an asset you are to a company that wants to hire you, or to, I don't know, activist movement that you're trying to pass a bill or make a new law or something, trying to get that noticed by the government. Knowledge is power. The more education you can get, the more you can do in life. So there are definitely bitter parts about education. Don't get me wrong. I have felt them too. But the fruit is very, very sweet. And I would like you to focus on the fruits, the fruit part, the sweet part. If you can focus on the sweet part of education and what it can do for you, that can keep you motivated. And I love to see people motivated to learn. So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.